Okay, you are welcome to today's class. What we have today is chemistry. But before we move over to what we have today, I would like us to have a review of the assignment I gave yesterday. The assignment I gave you on biology. So, did you do the assignment? Oh, yeah, I can see. I come out. Fast. Come back and talk to us. Tell us what you did. Okay. So what did you do? Tell us. Good. Difference between growth and development. Oh, yeah. What are the differences between growth and development? Good refers to what?
Physical change of an individual.
Physical change of an individual, okay?
Like size, increase in size, height, length, and weight. While development refers to overall changes in a physical organ or the structure that result in improved functioning of the physical body.
Okay.
Growth is purely physical change, while development is overall physical, mental, emotional, social, moral.
Okay. Growth is more what? Physical. Yes. Growth is more physical. I agree with that. You know that someone can grow and say, hey, Otogo, Manucho, Nwero. Have you heard of such things? So growth is just physical. The person just but the person is not developed what? Yet. And that's why you can see an adult like now, with small time now, that is, if when we met last year or last 2 years or last year, was it last year? Last 2 years? Last year's right? Last 2 years, August last July, right? That was long back now. When you came for lesson, what was that? No, I mean that was long vacation now. Okay. Yes, okay. I think that may be, is it Easter period or so? I can't remember. But whatever. You were smaller that time, but now we are now. Maybe you say we may even be the same height now. Growth. I'm not talking. When it comes to compare two of us now, he has grown. But when it comes to development, he has not developed to the extent I have developed, two of us, but he has grown. Boom, height. Look at my BS. Does he have BS? No BS yet. This one is what? Development, two of us. With time now, he may have BS. Two of us. But development is more, is encompassing, not just about physical growth, not height. Development is the development. That means in the interdevelopment, growth is also a part of the development. Two of us. Do you understand what I say now? Growth is part of what development. Oh yeah, continue.
Growth is only a part of development.
Oh, she said it now. Sir. Oh yeah, growth is what?
Only a part of the developmental process.
Okay, good.
While development is a complex and comprehensive process.
Good. Growth is part of developmental what? So growth is found inside what? Development. Just a part of what? Development. Continue.
Growth is limited to a certain age. It stops when maturity has been attained.
Okay.
Development is a continuous process, starting from the time of conception and continues, and it continues until the end of life.
So development is for life. Hello? Development is for what? It's for life. It continues. It doesn't stop but growth can stop at a particular point. I continue.
Changes produced in growth can be observed.
Come closer.
Changes produced in growth can be observed and measured directly.
Okay.
Developmental changes that result in improved behavior or functioning cannot be measured directly.
You see, you can measure what? Growth. That just look at, okay, the height is 5 cm. The height is, not cm, sorry. The height let's say 160 cm. You can measure the what? The growth. But you cannot measure, there are part of development you cannot measure. Psychologically, how somebody does, can I measure how you reason? Can I measure it? You cannot measure it. There's some part of the developmental process you cannot do what? Measure. Continue.
Growth focuses only on one aspect, that is increase in a child's body size.
Okay.
Increase in size.
Yes.
Development focuses on various aspects like interpersonal skills, intelligence.
I think I mentioned something like that. What you know, are you aware that you are coming here is part of your development? Academic what? Development. It's not just academic, mind. I am also developing your mind, because sometimes I will start telling you things that it's not chemistry, it's not physics. Sometimes I tell you something that will help you to grow in life, to achieve whatever you want to achieve in life. You may not see that one in the physics textbook. This is a part of what I'm contributing to your what? Development. Am I communicating? I continue.
Growth is an external process. Development is an internal process.
Is what?
Internal.
So development is more what? Comes from, is more of internal, right? Why growth is more of what? External. I continue. Because there are some part of your development that nobody can see, two of us. Can I see your organ? Can I see your kidney? Your liver? Can I see your kidney? Your kidney? See. How? Huh? Eh? I mean, normal. Can I just see your kidney? I cannot. It's more of what? Internal. And there are, even inside that kidney, development going on there is more what? Internal. Am I communicating? Continue.
Growth is structural. Development is functional.
Good. A very important point. Growth is what? Structural. I agree with you. But development is more of what? Functional. I agree with you. Mm-hmm.
Growth is influenced by development. Development is independent. It does not depend upon growth. It does not depend on growth.
Okay.
Growth can be influenced by both genetic and environmental factors, such as nutrition and exercise, while development is influenced by a wide range of factors, including genetics, environment, culture, and experience.
A lot of things contribute to your what? Development. Continue. How many points? 10. Oga? Come and tell us your own. How many times did you give yesterday? 4. The next one is what?
Lifespan of mosquitoes.
Yeah. So tell us. Fast.
Male mosquitoes live only 6 or 7 days.
Male mosquito live only what?
6 or 7
what? Days.
Feeding primarily on plant nectar and do not take blood meals. Female with an adequate food supply can live up to 5 months or longer.
Wait to male live how many?
6 or 7.
7 what?
Days.
Hey, female uncle?
5 months or longer.
5 good months or more. Continue.
Females with an adequate food supply can live up to 5 months or longer, with the average female lifespan being about 6 weeks.
Okay.
After a mosquito bites a person, the female mosquito can live for 100 days and can lay hundreds of eggs during their lifespan. Different mosquito species are found on different habitats. Some mosquitoes are considered floodwater, that is, species that breed in temporary water habitats, while others are considered permanent water, mosquitoes that breed in water sources that remain for long periods of time.
Okay. Continue.
All mosquitoes undergo the same 4 stages, that's their lifestyle.
Okay, that's okay.
Egg. Depending on the species, female mosquito lay her egg either individually or in attached groups called rafts. In some species, the egg may hatch within few days of being laid, with the exact amount of time depending on the temperature. The larval stage. Once the egg hatches, the larval stage begins. The larvae of most mosquito species hang suspended from the water surface because they need air to breathe. Larva filters feed on aquatic microorganisms near the water surface. The length of larva stage ranges from 4 to 14 days, varying with species, water temperature, and food availability. Then the pupa stage. In the pupa stage, no feeding occurs. However, the pupa must still breathe air at the water surface and is sensitive to light, shadows, and other disturbances. The pupa stage lasts from 1/2 to 4 days, after which the pupa skin splits around the back, allowing the newly formed adult to slowly emerge and rest on the surface of the water. Then that's the adult mosquito. The male adult mosquito will usually emerge first, and will
Okay, the male one emerges what first? Okay.
linger near the breeding site, waiting for the female. Mating occurs quickly after emergence due to high adult mortality rate. For the female to nourish and develop her egg, she must take a blood meal in addition to plant nectar. The average female mosquito flight range is between 1 and 10 miles, but some species can travel up to 14 miles before taking a blood meal. After each blood meal, the female will lay her egg, completing the life cycle.
Wow. So what they feed on mainly are what?
Plant nectar.
Blood and nectar. Okay. What other service that give?
Cold-blooded animals.
Let's talk about that one. Increase your voice. I want to. We are recording this. Increase your voice.
Cold-blooded animals are animals that cannot generate their own body temperature.
They cannot do what?
Generate their own body temperature.
Is it generate or regulate?
Generate.
Continue. I'm listening. Continue. We are listening.
Cannot generate their own body temperature.
Okay.
And must rely on the environment to regulate their body temperature.
Okay, good.
Warm-blooded animals are animals.
So what does this mean? If the environment is what? If the temperature in the environment is high, the temperature will become what? High. If the temperature of the environment is low, they will become what? What's under them they are called? Warm-blooded.
Cold-blooded.
Cold-blooded. Did you check?
Yes. Ectotem. Ectotem.
Ectotem. Are you sure?
Yes.
Ectotem. Let me see.
Ectotem.
Okay, continue.
Warm-blooded animals are animals that can generate their own body temperature and do not need to depend on the environment to regulate body temperature. Example of cold-blooded animals are fish and reptiles.
Cold.
Yes.
Okay.
Fish and reptiles. One example of warm-blooded animals are mammals.
Mammals, one example. Is that all? Is that all the assignments I gave? Let me see what other ones. What do the amoeba have flagella? So what do they have for the movement? Pseudopodia. Okay. Do you agree with her? Imeria. No, I will know. Do you agree with her? Good. Oh yeah, let's clap for her. Thank you. Okay, Maya, come. Back. Let's see what you did. Oh yeah. Tell us about growth and development.
Growth is quantitative.
Is what?
Quantitative.
Quantitative.
Development is both quantitative and qualitative.
Yeah, that's the point. Growth is quantitative. That means you can actually measure growth. True of course. Good. Anything that is quantitative, you can measure it, or you can count it. Quantity. Quantitative came from what? Quantity. But qualitative, quality. So you cannot actually, specifically measure it or count specifically, even though you can see they develop some yardstick, but you cannot exactly say this is what it is. But just you see how it is. You're more functional. Continue. Right.
Growth depends on age. Development occurs throughout the lifespan.
Good. I think she mentioned it.
Growth generally refers to structural change. Development refers to functional change.
Function. Strength and what is it again? Structure and what? Function. Okay?
Growth is measurable attribute. Development is both qualitative and quantitative.
Growth is okay. There's no way you cannot measure growth. But there are some aspects of the development actually there are some aspects of development you can do what? Measure anyway, but not all everything. You can still measure it, but there's some just as you mentioned psychological, the mindset and another thing, right? You cannot measure that one.
Growth ends at maturity. Development is consistent.
Is what?
Consistent.
Development is consistent. Increase your voice. We are looking at this note. Increase your voice.
Growth ends at maturity. Development is consistent.
Good. Put this in your mouth. Hold it. Put it in your mouth.
Growth occurs internally, and development growth occurs externally.
Externally, okay.
And development occurs internally.
I think she also mentioned it, right? That growth is what? External. Development is what? Internal. Oh, yeah. Is that all? Is that all it is? How many?
7.
Huh?
7.
7. Only 7. Each I don't get up. Okay, oh, yeah. Next one is what?
Cold-blooded animals.
What are they?
Cold-blooded animals.
Who is in that?
Cold-blooded animals are animals that regulate their body temperature
I agree with
by
you.
exchanging heat with their environment.
Cold-blooded animal
Yes.
can regulate their.
That regulate their body temperature by exchanging heat with their environment.
Okay, I'm listening. Continue.
Warm-blooded animals are animals that maintain a constant body temperature by generating heat internally. Warm-blooded animals are defined as animals that can regulate and maintain constant internal body temperature. They can survive in any temperature range as they can adapt to it easily. Example, mammals. Another name for cold-blooded animal is poikilotherms.
Boy, what?
Kilotherms.
Spell it.
Poikilotherms.
Poikilotherms or poikilothermic, and that one I want to say is that song. I want to find that yourself.
Example, insects, worms, fish, amphibians, and reptiles.
Okay. Is that all? Then, what are in that game? Okay, this is the only one you need. Okay. Call them. Fast. Which one do you need? What's that? Those are now is it those ones that have options again? No, I will look into that one together. Actually, when I come, those ones are question and answer. If I point to you, answer. That one, if I point to you, answer. So that one has options now, right? So if I point to you, you answer. That one has no issue. The one I'm talking about now is the one you did research on your own. Oh yeah.
Difference between growth and development.
Put your mouth in. Let's hear your voice.
Growth is defined as development of a person in weight, age, and
Okay, continue.
growth is defined as development of a person in weight, age, size, and habits. While development is the process whereby a person's growth is visible in relation to the physical, environmental, and social factors.
Okay.
Growth is just getting bigger, while development is improvement.
Is what?
Improvement.
Okay.
Growth is a physical change, while development is a physical as well as social or psychological change.
Okay, I agree.
Growth is dependent on cellular changes, while development is dependent on organizational transformation.
What do you mean? What do you know? What do you know? you are an organism, right? And we are at the level of what? Organization. As you are now, if you develop, okay, now watch out now. You grow low and are attaining this height. You may remain like this forever, okay, no. But you may change your face. Your voice will start becoming deeper. You start growing there. You start growing pot belly. You start growing chest. You know, these things are development. But the growth has not stop. But they're still developing. I'm not saying it is a kind of transformation. I agree with that, but continue.
Growth is quantitative, that is measurement based on some quantity or number rather than on some quality.
Okay, good.
Development is both quantitative and qualitative.
Good, I agree with you.
Then the study of amoeba.
Okay.
Amoeba, it is a single-celled, naked, colorless, microscopic, shapeless, and jelly-like animal. Then the structure of amoeba, we have cytoplasm, and that cytoplasm is divided into two. That is ectoplasm and endoplasm. Then the ecto is the outer non-granular liquid layer, while the endo is the inner granular layer. Then we have the cell membrane, and the function is to keep the cell contents together.
Okay, I agree.
Then we have contra. I pronounce this thing.
You don't know. Contractile vacuum.
Contractile vacuum.
But I just want you to, get yourself acquainted before we do it. Okay?
It excretes waste liquid products such as dissolved ammonia.
So, contractile vacuum is a basically what? Organism. Apart from it, or what? Amoeba. Continue.
Then we have the food vacuum. It provides site for the storage and dissection of food. We have nucleus. It is bounded by a nuclear membrane, and it carries chromosomes, which are hereditary units, and it initiates cell division.
Okay. Is that how you did?
Yes.
This is how you did. Thank you. Now, let's look at the assignments I gave. I think, what's time now? What's time? What? 5? Okay. Let's use a few minutes to look at the assignments I gave. Let's use a few minutes to look at the assignments I gave. Number 1 says what? Comes the answer number 1 fast. Come out here. Come out. Oh yeah. Answer number 1 for us. Read number 1 and read number 1 and tell us the answer. And why you chose that answer. You must know you're looking for your answer. 2 of us. Good.
A characteristic that can possibly be shared by both living and non-living.
Okay. Please go back again, please.
A characteristic that can possibly be shared by both living and non-living organisms is locomotion. Because
call the other options now.
Okay. A characteristic that can possibly be shared by both living and non-living organisms is A. Locomotion, B. Irritability, C. Increase in biomass, D. Increase in size.
Okay.
And the answer is locomotion, because living things move, but non-living things move unless it moves them by external factors. And irritability. Non-living things cannot respond to stimuli around the environment.
I listen to her. Are you sure? Okay.
Increase in biomass. Non-living things cannot.
What is biomass? You didn't take the human biomass. Look at. You know that if your assignment, you check. Then if you see some word, I will tell you. If you see a word that is somehow, you do what? Check it up. That's how to study. Don't worry. What do you get to your son? You answer that one. I continue.
Increase in size. Non-living things cannot increase in size. Like this, I cannot just increase in size. So the answer is locomotion.
Locomotion. Is that what you chose? I continue. Is that what you chose? She said what? Locomotion. Who agreed with her? Do you agree with her? Do you agree with her? Okay. All right. Oh, yeah, come on. Number 2. Come and answer number 2 for us. Fast.
The characteristics that exhibited by all living organisms are A. Sexual reproduction, B. Aerobic respiration, C. Ability to move from one place to another, D. Their ability to remove unwanted substances. The answer is C.
Why?
Because living organisms have the ability to move from one place to another.
What's the question again, please?
Their characteristics exhibited by all living organisms.
Okay. So does okay. Do you agree with me? Do you agree with me? Oh yeah, come. What do you think? Should be the answer. Go and give her the man. You sit there, you are the mother, and sit down there. Oh yeah. No, put it, give the man, madam. Oh yeah, tell us. What do you think? Why don't you agree with me? With reasons,
Okay. Because what all living things move now from one place to another.
Living organisms.
Okay. What's the reason?
Okay, you agree with him? Huh?
I don't agree with him. I don't know reason. I don't know.
Okay, you don't even know it.
But I know. But we know the same answer.
Okay, what's the other answer? The same answer. What's the other answer?
Aerobic respiration.
Aerobic respiration. It is what you choose. Aerobic. Do you agree with them? With her? Huh?
But it is living organisms, not living things.
Living organisms, do it. You're going to say what characteristics of living organisms share together? Option A is what?
Sexual reproduction.
Sexual reproduction. Does all living organisms undergo sexual reproduction? No. So that is this is very hard to answer question. If you are giving question in exam 1, try to look at all the options. So don't just conclude by looking at one option. It's wrong. So don't put that in a so it doesn't go up. Continue. You don't look at one option and do what? Conclude. So option A says what? So do you agree? So there are living organisms that are reproduced by asexual reproduction, right?
Yes.
Right? So that's not the answer. Option B says what? Okay, what's the other answer? Okay, you also agree with it. Let's go now. Aerobic what? Respiration. What is aerobic respiration?
Ability to respire with use of oxygen.
There are living organisms that respire without oxygen. Without oxygen. You don't know. We have anaerobes. We have oxygen that respire without what? Without what? Oxygen. So I wouldn't see that option. Next one is what?
Ability to move from one place to another.
These three standing here. Is it a living organism?
Yes.
Is it living? Is it living? The tree, is it living? Is it moving? So, he said from one. He said from one place. So the next option is what?
Ability to remove.
To remove. That's the answer. Even tree remove from one place. Don't you know? Don't know. Huh?
Yes.
Do they remove? Tell us how they remove. With the she asked how do trees remove unwanted things? Tell us an example.
Like example, cashew tree.
Cashew trees does what?
They remove gum and
Come, you see, they are what? Excreting what? Product. If you go to some tree, look at you see the gum coming out. This is not excreting what? Product. So tree remove. Is there any other example?
rubber tree.
Rubber tree. This rubber they use are excreting what? Product. Any other example?
Mango tree.
So trees are also both living organisms. If they don't remove on one side, they will die now. The prophet told it to the three of us. They will die. So that is the best option. Have you seen how to answer obedient question? Be careful, don't just jump and pick one thing. Look at you yourself know it, but you know it, but now you now you forgot that tree. You are looking at it. You cannot move. Have you ever seen tree moving around? You say that living things and living things are not the same thing.
Yes.
They are living. It's living organisms that they are living. They are living. Okay? Alright. Now, the next question says what? And I teach will come out here. Come and answer the third one, right? Oh yeah.
The ability of a living organism to detect and respond to changes in the environment is referred to as A. Growth, B. Toxins, C. Locomotion, D. Irritability. The answer is irritability.
Why?
Because irritability is response to stimulus.
Do you agree with that? Do you agree with that? Good. Thank you. Next question, Aya. Next question, Aya. What did next question say?
All living organisms. A. Photosynthesize.
All you have to do what?
A. Okay, is it the answer?
No, you just continue, just read everything.
A. Photosynthesize. B. Respire. C. Move. D. Feed.
What's the answer?
Respire.
Respire. Respire. Okay. Why do you say respire? Start from B. Tell us why the other options are not correct. That has to know whether you know something. See, if you are given an assignment, if I give you assignment, after today, if I give you assignment again, don't just look at as you are reading through your textbook to solve it as assignment. See how to study. Baby, if you do this thing I'm telling you now, if you get measurement, if you get one, I got it. See. If you see options, the assignment I'm giving you, both the OBJ and theory, especially OBJ, if you see options, don't just look at the option you are seeing there, the correct option, and run away. Try to find out why the other options are not correct. That's what I want you to learn. Find out why the other options are not what? Correct. So that in case they change that pattern, sometimes they may change the options. If you don't know why the options you made last year is not correct, you go again. The question may be too set for the answer to be the option B. There's a question you will see last year. The answer is option B. When you go to the following year, they will twist it, but the same question. So you try to understand why the other options are not correct. So tell me, pick the options, pick the four options, one after the other, and tell me why the one you chose is correct and why the other ones are not correct. That's what I want you to do. Fast.
A. Photosynthesize.
Okay.
Photosynthesis is the ability of living organisms to produce food through sunlight, carbon dioxide, and chemicals. And living organisms will not feed through photosynthesis.
We not do what?
Living organisms don't photosynthesize. They do not produce their food from sunlight. It's only plants that photosynthesize.
What is plant?
It's not all living organisms.
It's plant an organism.
Okay, organism.
Huh? I think that's what it is. Plant an organism. What is plant? It's plant an organism. I think you had that issue before. Whether plant is an organism. What is an organism in the first place? From the term organism, what is an organism? These are what we should ask ourselves. So what is it that plant is not a living organism? So what is plant? If plant is not a living organism, what it is?
I don't know.
Okay. Is there a between living thing and living organism? Are you a living thing? Are you a living organism? But it's okay. Please, let us not confuse ourselves. Anything that has life in it is a living organism. Okay? Now, when you not come there, when you not come down to living organism, you have plants and what? Animals. Am I coming to this? Now, answer the question. Why is you say for this first of all, the question says, if you read the question again, the question alone says what?
All living organisms. Dash. No.
So is are all living organisms photosynthesized?
No.
Huh? All living organisms photosynthesized. So which one photosynthesized? Plant. Green plant, please. Chlorophyll, green what? Plant. Plant that have what? Green pigment. These are the ones that photosynthesize. So have you seen why that is not the answer? Then go to option B.
Option B was fire. All living organisms was fire.
Are you sure? Are you sure? Okay. Is that the answer you chose? The third one, Nico?
Move. Move.
Move, Nico. Do all living organisms move? Move. Is it move the road there? The question is somehow, but it's okay. I think respire has more power. You know, move, if you start breaking down with the move can be okay. The question is that the option is ambiguous. But another thing I want to know is this. If you go to JAM examination, please, JAM may get 3 options, 4 options that have something to do with the question. But you choose the most appropriate what? Option. Among these things, can you get the more power? Can you get the cow? Which of them has more weight now? Respire. Because if they don't respire, they will do what? Die. You choose respire. Even though they can still move, but choose what? Respire. Because if they don't respire, they will do what? Instantly they will die. Life will just disappear because there will be no image, there will nothing. 2 of us. Good. Now, so, the last one is what? Feed. If you're not here, you will be confused with if you see feed. If you see feed, you see respire, you see move, you go confused. All these not respire now. All these not move now because plant can move. 2 of us. You know, yes, but all these not feed. It feeds the nutrition. Feeding is more likened to animal feeding. I'm not committing. Does plant feed? Feeding is more. It tilts more towards what? Even though they interchange it more towards what? Animal. The plant they mentioned they attach feeding to are carnivorous plants. You know there are plants that are what? Carnivorous. I think I mentioned it here. Did any of you bother to start research on carnivorous plants? Did any of you bother to research on it? Please, whenever I start information, go put it down. Just if you take anything, look at it. Know what it is. Now, if you look at these 3 options, the one that has more weight is what? Respire. You pick what? Respire. This is how to select options. So what is the answer?
Respire.
Do you agree with that? Do you agree with that? Good. Oh yeah. How many questions have you answered now? Is it four questions I gave? Oh yeah, come. Answer number 5 question.
The smallest living organism which share the characteristics of both living and non-living matter. A. Bacteria. B. Fungi. C. Viruses. D. Protozoa. C.
C is what?
Viruses.
So why is not bacteria? Why is not bacteria? Tell us. Tell us why is not bacteria. Do you agree with that? Sam? Do you agree with him? So tell us why didn't you choose bacteria? Any idea? So why didn't you choose bacteria? Since you agree with him, why didn't you choose bacteria? Huh? When it is what? Good to have. Yeah, mine. What bacteria is what?
Inside somebody's body, it's still a living organism. And when it's outside somebody's body, it's also a living organism.
Correct. You have a point there, but read the question again.
The smallest living organism which share the characteristics of both living and non-living matter.
So, your answer is correct, but there's something you add there. What you do, you should have ended up with by saying that bacteria is living organism, whether it's outside or what inside. It doesn't share any non-living characteristics. Two of us is what a living organism. So next one is what?
Fungi.
Fungi. Why didn't you choose fungi? Why did you jump to option C and choose virus?
Fungi is not a living thing, a living organism.
It's not. Fungi. Hey! Alpha. It's okay. Do you agree with me? That fungi is not a living organism? Do you agree with me that fungi is not a living organism? Come here. And it's what?
It's a living organism.
Why is your phone on? Are you checking on what?
No, I'm not checking.
Why are you online?
Because I'm...
Okay, you're browsing?
No.
Okay, I understand. Okay, answer now, is fungi a living organism?
Yes.
Good. So fungi is a living organism, so it doesn't share anything like that with knowledge. So that's why that's not the answer. The last option is what? Last option is what?
Protozoa.
So why didn't you choose protozoa?
No idea.
No idea. Oh yeah. No idea too. Protozoa.
Protozoa. It's a living organism.
Living organism, right? Good. Protozoa is a living organism. Alright, thank you very much for the assignment. Clap for yourself. Clap for yourself. Clap for yourself. Clap for yourself. Thank you. Now let's go to what we have. Where did we stop in chemistry? Where did we stop in chemistry? Compounds. Good. We talked about classification of what? Matter, right? Classification of matter. We said in our last class, I think that's where we stopped, that matter is classified into what? 3. We named them what? Elements, what? Compounds, and what? and what? Mixture. Now, we started with elements. We discussed elements. And we said that element is very into what? We have non-metal, metals, non-metals, metalloids, right? Then we move down to difference between the physical properties of metals and non-metals. The same way we talked about the difference between the chemical properties of what? Metal and what? Non-metal. We define what metal is. And after that, we now went to what? Compounds. And we define compounds as what? What's a compound? Is what? Good. We say that compounds are what? A compound is a mixture which contains two or more elements that are chemically combined together. And we slightly made a distinction between compounds and what? Mixtures. When I say that mixtures are not chemically what? Combined, right? They are just there. Just like I can remember I gave an example with sand and sugar or salt, right? I said that if you pour sand is a compound, but soil is a mixture. Sand is a compound, but soil is a mixture. Sand has a chemical formula. Are you aware? It shock you. Sand is a compound. It has a what? It has a formula. Don't worry about it. I will treat it in what? Compound. We are in compound now. So sand is a compound, but soil is not a compound. Soil is a mixture. Soil has sand and other components that make up the soil. So soil is a mixture, but sand is a what? Compound. Now let's go. And I told you that compounds are chemically combined, and they combined at a fixed what ratio, right? And I told you that irrespective of the form the compound takes. I use water as an example. I tell you that the component elements of water, like hydrogen and oxygen, are combined in ratio of what? 2:1. Whether the water is ice block, is ice, whether it's what? Gas, it doesn't matter. It must be combined. Hydrogen and oxygen will always be combined in ratio of what? 2:1. That's why we have H2O. H2O, water. We have H2O. As you can see here now, hydrogen is what? While oxygen is what? So they are combined in ratio of 2:1. Is it clear? These are things we discussed in our last class. We also give example with carbon dioxide. Carbon and what? The component elements of carbon dioxide are carbon and what? Oxygen. Carbon and what? Oxygen. Carbon is 2 here, 1, right? Oxygen is what? 2. So carbon combined with oxygen in ratio of 1:2 to form carbon dioxide. The same thing with carbon dioxide. In carbon dioxide is simply CO. Carbon is combined with oxygen in ratio of what? 1:1 in carbon dioxide to form carbon dioxide. So anywhere you see carbon dioxide, however it appears, so far it is carbon dioxide, carbon must always combine with oxygen in ratio of what? 1:2. 1:1 is a must. That's the point we made in our last class. Now we want to talk about examples of compounds and the element they contain and their formula. Are we together? Examples of compounds, the element they contain and their what? Formula. Now let's look at water. I think we mentioned water, right? We've been talking about water. So water is a compound, please. Remember, water is what? A compound. Water is a what? A compound. Water contains hydrogen and what? Oxygen. Hydrogen and what? Oxygen. And the formula is what? Look at formula H what? 2O. Hydrogen and oxygen. They are combined in ratio of what? 2:1. So water is a what? Compound. Any compound, anything that doesn't have a formula is not a compound. Note that. A compound must have a what? Formula. It is a must. It is a what? A must. Now, sand. Another compound I want to talk about is sand. 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 Sand contains silicon and oxygen. Sand contains what? Silicon and oxygen. So sand, look at it. Silicon what? Outside. Are we together? See silicon, see what? Oxygen. So this is the formula for what? Sand. Silicon and what? Oxygen. Sorry. Put 2, please. Put 2 here. After oxygen, put 2. I wouldn't want to. Anyway, it's okay. Look at it. What is the oxidation number of? Okay, we've not done oxidation number, but you should know that one by now. What's the oxidation number of silicon in this compound? Who can tell me? Solve it and tell me. Who can tell me? Now. Hey, silicon what? Silicon what oxide? Is this silicon 2 oxide or silicon 4 oxide? 4, right? Are you sure? Are you sure? Are you sure? Now, let's go to the next one, please. That's the formula. Just note it. By the time you appreciate it better when we start, when we move over to chemical formulas, and that's when we learn how to name compounds. Okay? Let's continue. Limestone. Limestone contains what? Calcium, carbon, and oxygen. Limestone is composed of what? As I said, that water contains what? Silicon and what? Oxygen. We have FiO2. Oh, sorry. Sand, not water. Sorry. Thank you. Sand. Then water is what? Hydrogen and what? Oxygen. Right. Then next one is what? Limestone. Limestone is what? CaCO3. Contains what? Calcium, carbon and what? Oxygen. So limestone is composed of what? Calcium, carbon and what? Oxygen. Then common salt. What is common salt? Common salt is salt you use. Common salt, normal salt we use in cooking. That our normal cooking table salt. Common salt is composed of what? Sodium and chlorine. Common salt is composed of what? See the formula here. NaCl. Sodium chloride. It's composed of what? Sodium and what? Chlorine. These are the elements in what? Common salt. Then sugar. The sugar. Our sugar, we know. Another name is fructose. Fructose. These are the sugar. Our normal sugar we know. Fructose. Sorry, sucrose, not fructose. Sorry, sucrose. Are you aware that glucose is a sugar, right? But normal sugar you used to put after making a pap. You put sugar, cube of sugar you buy in the market, or you go and buy what do you call it again? Or you buy you buy gari and you soak gari with sugar. That sugar you buy, either the powder one, the grounded one, or either the granulated one, or the what? The cube one. That sugar is what? Sucrose. Another one is what? Sucrose. So the sucrose we use in bracket put sugar is composed. The formula is C22. The formula is C12H22O11. C subscript 12H subscript 22O subscript 11. This is the formula for what? Sucrose. Huh? Huh? Yes. I will say, from this formula, you should know the elements now. The elements are what? Carbon, hydrogen, and what? Oxygen. Carbon, hydrogen, and what? Oxygen. These are the components of what? Of what? Sugar. The other one is what? Ethanol. Ethanol. The component elements in ethanol are carbon, hydrogen, and oxygen, but they are combined in different ratio. What are there's something I want to point out here. If you watch, you will realize that sugar and ethanol, they have the same component element. True or false? True or false? Good. But they don't have the same formula. Do you know why? Those atoms, those elements are combined in different words, ratios. Are we together? They are combined in different words, ratios. That's why they don't have the same word formula. So a particular compound may have a specific ratio in which they do what? Combine. Am I communicating? Now, so you have ethanol. Ethanol is C2H5OH. C2H5OH. That's the formula for what? Ethanol. The component elements are what? Carbon, hydrogen, and what? Oxygen. Now, the next one I want us to look at. The next compound, we have our washing soda. Washing soda. Washing soda contains the component elements in washing soda is sodium, carbon, oxygen, and hydrogen. Sodium. Anytime you hear soda, hello? Anytime you hear soda, no that sodium is what? Involved in one word or the other. Am I communicating? So we have sodium. What? Carbon, hydrogen, and what? Oxygen. These are the component elements of what? Washing soda. And the formula is this. Na subscript 2 CO3 sub CO3 dots. Then you write 10 H2O. Na subscript 2 CO subscript 3 dots 10 H2O. That is sodium triiodocarbonate 4 decanoate. Decahydrate, not decanoate, decahydrate. Sodium triiodocarbonate 4 decawatt hydrate. It has 10 molecules of what? Water of what? Crystallization. That's what we see all those things. If you watch, I'm trying not to call chemical names because I don't want you to get confused. We'll still take it step by step and get it, but sometimes it's good to mention it because it's from mentioning it become part of you. This is actually sodium triiodocarbonate 4 decawatt hydrate. If that 10 in front of water is 5, it becomes what? Pentawatt hydrate. It becomes what? Pentawatt hydrate. So this is sodium triiodocarbonate 4 decahydrate is known as what? Washing soda. So it's a compound. It's a what? It's a compound. Another one is hard soap. Hard as in hard. Soup, yeah. Hard soup. component elements are what? Sodium, hydrogen, carbon, oxygen. The same thing with washing soda. So hard soap and washing soda have the same component element, but they're not combined in the same what? Ratio. That's why they have the same different chemical what? Formula. Washing soda and hard soap, they contain the same component elements. Note this important point. But they are combined in different, but they're not combined in the same what? Ratio. They are not combined in what? The same what? Ratio. The same what? Ratio. Now, hard soap. Did I write the formula for? Okay, the formula for washing soda is Ca2 subscript CO3 subscript 10 molecule of what? Water of crystallization. Sodium triiodocarbonate 4 decahydrate. Hydrate means water of what? Crystallization. It's a hydrated salt, right? Now, look at this thing. Look at what we do. What did I say? You just said that they have the same. Yes. They have the same component element. Hard soap also have what? Sodium, carbon, hydrogen, and what? Oxygen. But now look at the salt. Look at the formula for what? Hard soap. Formula for what? Hard soap. Hard soap is an ethanoate. Is an alkanoate from arachidonic acid. It's a salt formed from arachidonic acid between. I don't want to go into organic chemistry, but let's take it step by step, okay? Yes. Who among you have done organic chemistry before? Okay, you done in school. You know what I'm talking about, right? You don't know. Okay. For the bit of those that have not done it, let me not confuse you more. Just see the formula. You have C17H35 COO and what? A. This is a salt. Then what is called esterification? It's an esterification. It's an ester. Better called an ester, not just a salt. Because if you say salt, it tilts towards more inorganic. Let's leave it as what? Ester, right? Let me stop here, please. Let's not talk too much on this, please. Yeah, that's formula for what? Hard soup. C17 subscript 17. Ester ESTER. But it's a salt too. You know, inorganic compound is now involved. Am I communicating? Inorganic compound is now involved, and this Na must definitely come from what? Sodium hydroxide, true of course. Why did this the other part will come from what? From what? Arachidonic acid. Or sodium in this salt, I don't want to go to organic chemistry. Have you done organic chemistry in your school? At all. They don't mention it in your school. You are in SS what? Okay. Let me not confuse you. Just stop here. We are still in the introduction of chemistry. We are still at the elements of chemistry. Let them not jump and start confusing her, okay? But you ask a question, right? I can answer your question. You ask in this now, which one is inorganic? Sodium is inorganic. From this place, this side is organic. Is it clear now? Is it clear? Let me stop here. So this is the formula for what? For what? Hard soup. If you watch, it has It has sodium, right? Oxygen, right? Hydrogen, right? And what? Carbon. But they are not combined in the same what? Ratio. Look at washing soda. It has the same component elements, but are they combined in the same ratio? All right, let's continue. We also have caustic soda. Is another compound, caustic soda. Caustic soda. Caustic soda is composed of sodium, oxygen, and what? Hydrogen. Caustic soda doesn't have carbon, no. It has only, caustic soda doesn't have carbon, it's inorganic. Caustic soda is what? Inorganic. So caustic soda composed of what? Sodium, hydrogen, and what? Oxygen. Is what? Inorganic. So another name, IUPAC name is what? Sodium hydroxide. Sodium what? Hydroxide. That's the IUPAC name for what? For what? For what? Caustic soda. Sodium hydroxide. NaO what? H. Sodium hydroxide. What's time? Okay. Let's move with the speed of light. Then these are compounds. Are you together? Then what are mixtures? What are mixtures? Let's look at mixtures. This is not the only example of compound we know. I just gave you all these ones for you to understand. You can find out more on your own and make up your notes. What are mixtures? Any idea? What are mixtures? What are mixtures? Oh yeah. No idea. Mixtures are what? Are what? You said that mixtures are what?
Combination of two substances.
That is what? Comes here. What are mixtures? No idea. Israel. What are mixtures? Hey! We have committed chemistry blunder now. We have committed chemistry crime. What's the mixtures are compound? They are not compound, okay? Alright, let me explain. If you get salt and salt, I think I have mentioned it before. If you get salt and get sand, get water, get beans, just get different things and put them together. If those things are not reacting, if they are not reacting to form a different thing altogether. That thing you brought together and put in the same, combined together, is a what? Mixture. It came from the term mixing things. Don't know what is mixing things? That is a what? Mixture. So a mixture is a substance that contains what? Two or more constituents that can be separated, that can be easily separated by what? Physical methods. A mixture is a substance that does what? Contains two or more constituents that can easily be separated by physical what? Physical what? Methods. That's a mixture. So those constituents of the mixture are not chemically what? They are not chemically what? Combined. That's why they can easily be separated by physical what? Methods. And these constituents of mixture, they can be elements or what? Compounds. Hello? The constituent of mixture can be what? Element or what? Compound. You can see a mixture that is composed of compounds, 2 or more compounds, or a compound and a mixture, or element. Am I getting? You will also see a mixture that contains what? Different elements. Different what? Elements. Now, let's look at examples of mixtures. We'll look at examples of mixtures and the difference between, after that, we'll look at the difference between mixture and what? Compound. When we are done, I'll give assignment. Then we'll say bye-bye for today. Sit up. Now, let's look at examples of mixture and their constituents, or their constituents, or their components. Anyone? Air is a mixture. Are you aware? Are you aware? Air is a what? Air is a mixture. Yes. Air is a mixture. What are the components of air? What are the components of air? What are the components of air? In the air, you have moisture is there. Moisture is there. You have moisture. Oxygen is there. Oxygen is there. Carbon dioxide is there in the air. Carbon dioxide. Nitrogen is there. Then rare gases are also there. Rare gases. You call them rare gases or what? Noble what? Gases. Rare gases or what? Noble what? You call them rare gases or what? Noble gases. So air is a mixture. Air is composed. There are some. If you want to know whether air is a mixture, there are some experiments you will conduct. You will see that. Let me not go there, because there are experiments you can conduct. You can detect the presence of oxygen in what? Air. There's also the experiment you can conduct. You can prove. You can confirm the presence of carbon dioxide in what? Air. If you use alkaline pyrogalol or use lime water or quicklime, let's not go there. With time, do you agree with me? Do you agree with me? She do like this. Yes. Have you come across such thing before? But air is a mixture. Now let's continue. Soil. Soil is also a mixture. Yes. Soil is a mixture. Did I mention dust? Dust is also found in air, true or false? Dust. Did I mention dust as a constituent of air? So put that one down too. Soil. Soil is a mixture. Soil is composed of sand. Sand is there. It shocks you. Soil contains what? Soil is a mixture of sand, clay, humus. Humus. Sand, clay, humus. Water is. Are you aware that water is in the soil too? Are you aware? Are you aware? Soil. Water is also there. Air is in the soil. Air is also in the soil. The mineral salts are in the soil too. So you have sand, clay, humus, water, and mineral what? Salt. Even your urine. Your urine is a mixture. It shock you? It shock you? Your urine is a mixture. Urine is also a mixture. What are the components of urine? Urine, you have what? Urea. Urine, you have what? Urine, you have what? You have urea there. You have water and mineral salts. Urine. Please, anything you didn't get the spelling, please don't spoil it. Let me know. Urea, water, and what? And what? Mineral what? Salts. Mineral what? Salts. Palm wine is a mixture. Nkwocha. Palm wine is a what? Mixture. Palm wine is a mixture. What does palm wine contain? Okanko, there are many of them, but you have water. Water is there. Water is in palm wine. Sugar is also in what? Palm wine. Alkanol. Alkanol is in palm wine too. Mineral salts are also in palm wine. Vitamins is in palm wine. Even yeast. Yeast is also in what? Palm wine. Proteins, fat. These things are present in what? Palm wine. So palm wine is a what? Is a mixture. Palm wine is a what? Is a mixture. Even Coca-Cola, this Coca-Cola you are drinking, Coca-Cola is also a what? Is also a what? A mixture. What does Coca-Cola contain? There's what is called Coca-Cola. You know, have you heard of? Hey, I'll take you. If I start mentioning concentrate, Have you come across the term concentrate? Concentrate, have you? What's a concentrate? Animal what? What do you know about concentrate in animal feed?
Concentrate is protein.
Mm-hmm.
The energy giving food.
Mm-hmm. Is that all you know about concentrate? Tell me what's you know about concentrate? Come see.
I don't know the meaning.
Anyway, sit up. Yeah. Why are you saying like that? Concept. Now let me explain. Concentrate came from concentrated. What is concentrate? What is highly what? Concentrated. So concentrate is the noun form of it. Am I communicating? If you say that something is concentrated, the noun form of it is concentrated. Now, what's a concentrate? Is it concentrate? Is it a noun or adjective? I think it's more concentrate is more like. Anyway, it can act as both depending. This is not English language class. Now let me explain what I mean by concentrate. Have you seen have you seen some products that may come in powder form? But before you use them, you put them in you put water, and you add water in them before you can use it. Have you they try to dilute it with some water to some extent before you use it. Have you come across such thing? It can be what you eat, it can be what you drink, it can be what you use in cleaning your house. But you must put water, small amount of water. You must put water. Maybe they want to use it. They take small quantity of it, then add water in it before you use it. That is the concentrate. It's highly concentrated. Before you use it, you have to dilute it to some extent, to the volume you want to do what? Use. Before you do what? Use them. So this Coca-Cola you are drinking, Coke you are drinking, is a mixture that has, in that mixture, you have Coca-Cola concentrates. It's in the mixture. Am I communicating? So Coca-Cola is a mixture of one. We have what's called Coca-Cola concentrates. Coca-Cola concentrate. Coca-Cola concentrate. Coca-Cola concentrate. Coca-Cola what? Concentrate. Then we have, inside it, we have carbon dioxide. Are you aware that the Coke you drink, not only Coke, the soft drink you take have carbon dioxide? Are you aware? That is what gives you the refreshing what? Taste. Have you done carbon and its compound in your school? Have you? So you should know when I say that carbon dioxide gives, it's a popular issue now, carbon dioxide gives the soft drink their refreshing what? Taste. If there's no carbon dioxide, they will not have that refreshing taste. If you open it, you notice that the gas do what? Come out, right? It gives that drink what? The refreshing taste. Have you? Now let me explain what I mean by refreshing taste. Let's assume now, have you ever opened a drink, not the one that comes in a plastic bottle, maybe normal glass bottle that has cork. Have you ever opened it, then pour it in a cup and keep, or pour it somewhere else and keep, then come back the next day to drink it? How does it taste? Have you tried it before? Okay, you won't understand what I'm saying. If you open Coca-Cola now and pour in a cup and keep it for some time, maybe over till tomorrow, or pour it in ordinary bottle, leave the gas to leave the bottle, then pour the water, the Coca-Cola inside another bottle or tumbler or what have you, and keep it the next day. If you open it and drink, it won't be free. It won't be refreshing. The taste will. Sometimes you'll be like, how is it? The taste will be somehow. It will not be refreshing. But if you open it, the bottle, put it in the mouth, you feel like drinking more. Three of us. Has it ever happened to you before? Have you ever gone to occasion? Whatever, get bottle or either food flour, either water bottle, and open Coke and pour inside it, and take it maybe after some hours. It will be refreshing. Have you done it before? You cannot compare it when you open the bottle and drink it. It will be refreshing. You feel like taking more. Hello? That's what carbon dioxide does. So Coca-Cola has what? Carbon dioxide in it. That's why they call them carbonated drinks. That's why they call them what? Carbonated what? Have you heard of the term carbonated? Carbonated drinks, because they contain carbon dioxide. Hello? Carbonated what? I don't want to go into that. When we do carbon and its compound, we explain this more. But I just want to mention it so that you know that such thing exists. So it also contains sugar and water. So Coca-Cola contains Coca-Cola concentrate, carbon dioxide, sugar, water. So it's a mixture. Even the milk you drink, even the milk is also a mixture. The milk is also a what? A mixture. Milk is also a what? A mixture. Milk contains vitamins, mineral salts, sugar, water, proteins, and fat. It contains vitamins, mineral salts, water, sugar, fats, proteins. Seawater is also a what? A mixture. Seawater is also a what? A mixture. Seawater contains water, mineral salts, bacteria, and remains of organic matter. Remains of what? Organic matter. Seawater is composed of water, seawater, sea. It's composed of water, sugar, fats, proteins, mineral salts, and what? Vitamins. Sorry, what did I say now? What did I say now? Contains what? Call it again, please. Call what I called for you. First one is what? Good, thank you, please. Don't mind me. You know that sometimes human brain fires. Have you ever tried to do such? Have you ever said something? What you are thinking is different from what you are saying. Has it ever happened? If you say, when he's getting tired, since morning I've been working. Did you meet me working? Since morning I've been up. I've been here since morning working. So sometimes you can fire, but no problem. Just please don't write the second one I called, please. Are you aware that your blood is a mixture? Are you aware? Blood is a mixture. It shock you? It shock you? Blood is a mixture. Blood contains a lot of things. Okay, look at that. Now let me give you an instance why blood is a mixture. If you eat food, if you eat food, the food you eat will do what? Will get digested, right? And get assimilated. What carries it? Blood. The food particle, the food nutrients you see will appear in your blood. It's not a mixture. It's a mixture. Okay. The carbon dioxide your cell produce after respiration. Remember that, what I told you about respiration. The carbon dioxide your cells produce after respiration. Where they enter? From the cell to where? Blood now. From the cell to the capillary. It's not true. From the cells of the organ, they will come together and enter the what? Capillary. And they will pass through the blood, right? So blood is a what? A mixture. So blood contains what? Carbon dioxide, two of us. Now, the air you breathe in from the lungs, they go to the alveoli. At the alveoli, their capillary is there. They will enter those capillaries in the alveoli. Where would they go again? They will enter blood. So blood also contains what? Oxygen. So blood is a what? A mixture. Let me list some components of blood. Have you heard of the fact that have you heard that blood contains red blood cells? So red blood cells is that a mixture? It's a mixture. So cells are also there. Now let me list some components of what? Blood. Water. Do you agree with me? That water is in blood. Do you agree with me? Good. Blood. Protein. You know where protein came from now? The food you ate, right? The nutrients, right? From the food you ate, right? Fat is also there. Oil is also in the blood. Sugar. Vitamins. Hormones. There are also enzymes in the blood. I mentioned blood cells, right? Right? Blood cells. You see, what you say? No. It's red blood cells, not blood cells. Even white blood cells. Let's not go deep. What of hemoglobin? Is there hemoglobin in the blood? So it's a mixture. There are other components. Crude oil. The crude oil or petroleum, either I call it crude oil or call it petroleum, is also a mixture. By the time we do separation techniques, you understand that crude oil is a mixture. Because crude oil can be, component of crude oil can be separated by what method? You should know it. Fractional what? Fractional what? Good. Component of crude oil can be separated by what? Fractional what? Distillation. The component can be separated by what? Fractional what? Distillation. That's why I will say that crude oil is a what? Is a mixture. Is a what? Is a mixture. So crude oil contains things like petrol. It's when they distill, when they fractionally distill crude oil, you get your what? The petrol used in fueling your car or your generator. That's where they get the gas used in cooking, gasoline. That's where they get the gas they use in driving vehicles. That's where they get the coal tar they use to tar the road. There are many components you can get. Yes. You don't know? Huh? Where does coal come from? Huh? Cool. I like what you said now. I'm coming. The class is becoming enjoyable now. I like what you said now. Ask question if you're confused. Can you hear me now? Now, what happens is this. I mentioned what? Coal tar, right? Sorry. I wanted to talk about bitumen. As you said, coal tar is from where? From what? Coal, crude coal. I'm not communicating. But it's not actually a natural product. It's more of synthetic. But let me not go there. But the point is that both of them, bitumen and coal tar, they serve the same what? Purpose. But nowadays bitumen is more. So, but bitumen is from where? Crude oil. I'm not communicating. You can use bitumen for what? For what? Road what? Construction. That's what I was referring to when I said what? Coal what? Tar. So if you fractionally distillate crude oil, you get what? Bitumen is part of it. I'm not getting. That's what I wanted to say. What I was talking about. That was what was in my mind. But I wanted to confirm something. I wanted to confirm something. Are we together? Good. So it's when coal is destroyed thermally. Am I communicating? That's when you do what? You produce what? Coal tar. But bitumen is natural. When you distillate crude oil, you get what? Coal tar. Sorry, you get what? Bitumen. Am I communicating? Good. Thank you for that. I like a class like this. Not because I will keep quiet, you'll be talking. Sometimes you make a mistake. Everybody will carry it like that and go. I like that. Now let's conclude. Let's conclude. Now, so crude oil contains what? Petrol, heavy oil, gas oil, kerosene, naphtha, then bitumen I mentioned, right? The bitumen I what? Mentioned. See, it's spelled here, bitumen. Bitumen. It contains what? Petrol. Because if you distill it, you see petrol will be separated. Heavy oil will be separated. Even gas oil, kerosene, naphtha, bitumen, etc. Good. The brass. Have you heard of alloy? Have you heard of alloy before? Alloy is a mixture of what? Two or more what? Metals. Am I communicating? That forms an alloy. Something like brass. Brass contains copper and zinc. There are different alloys. So alloy is also a mixture. Brass is a mixture. The zinc and copper are not reacting. There. Am I communicating? They are mixture. So an alloy is composed of what? One or two what? Metals that combine. So brass is one of them. Even bronze. Bronze is also an alloy. Bronze is also an alloy. There are many of them. So this is where we'll stop for today's class. It's already, or it's almost 6:30, and I'm even tired. Do you continue? Do you continue? Chinwe, do you continue? Everybody is tired. So this is how I want my class to be. Please, I want my class to be challenging. Try to study. Come here. If I say something, you feel free to ask questions about that. It may not necessarily be to show that you may not necessarily be to maybe how do I put it? Don't feel like maybe if you want to talk, maybe I'll feel that no, just say it. Say it. From what he asked now about quota, when I mentioned quota, didn't you did you learn something from it? Distinguishing between bitumen and what? Quota. I didn't hear the question now. I would have mistakenly mentioned quota and go. But quota is from what? Coal. If you destroy coal, thermal destruction of coal, you produce what? Of course, if you study carbon and its compound, you know what is coke and coal. Am I complicating? You know that one very well. You know that one very well. But bitumen is from, even though two of them contain carbon, hope you know. Two of us. They both contain what carbon, and they're not from the same source. They're not from the same source. But bitumen is gradually, in fact, is coal. Coal for coal tar is gradually going down now. It's not that much in use again, but just know that they can serve the same purpose, but they are not from the same source, even though they contain what? Carbon. All right, these things are what we're going to discuss when we talk about carbon and its what? Compound. This our today's class started late. My target is that once it's 6 o'clock, you guys will start going because of how the road is. Now I don't know now. The assignments are there, we will take it out. But whatever it is, we must give what? Assignment. It's a must. Whether we like it or not, we must give what? Assignments. That's what keeps us what? Going. That's what keeps us what? Going. So we must give assignment. I take it. Number 1. To better house more, we must give assignment. Okay, let me look at assignment. Number 1. Which of the following substances is a mixture? Which of the following substances is a mixture? A. Granulated sugar. Granulated sugar. B. Seawater. Seawater. C. Sodium chloride. D. Iron filings. Iron filings. F-I-L-L-I-N-G-S. Iron filings. Iron filings. Then, number 5. Number 5. Sorry, number 2, sorry. Number 2. Or see what will happen. Have you written number 2? Have you written number 2? See what will happen. I want us, let's give more options. Let's move down a bit. Write number, you saw the number D, right? Option D. Write option E. Write option E. Sulfur powder. Sulfur powder. Bronze. Bronze. Distilled water. Ethanol. Sand. That's option again. E or H. Sand, you do sand. Washing soda. Washing soda. Common salt. Blood. Rubber latex. Rubber latex. Rubber latex. Vulcanizer's solution. About vulcanizer. Vulcanizer's what? Solution. Carbon 2 sulfide. Carbon 2 sulfide. Carbon 2 sulfide. Then the second question, number 2. Which of the compounds is composed of aluminium? Which of the compounds is composed of aluminium, silicon, oxygen, and hydrogen? Which of the compounds is composed of aluminium, silicon, oxygen, and hydrogen? Then number 3. Number 3. Which of the following changes is physical? Number 3. Huh? Which one? Which one? No, I said cancel that number 2. Sorry, cancel. What did you write to me? No. Number 2 is different now. Did I call the options number 2? Sorry. The options are A. Hey. The brain is firing. No? A is what? A is Epsom salt. Epsom salt. EPSOM. EPSOM. Epsom salt. Limestone. C is your Epsom. Now, if you want to do this assignment now, and you see this Epsom salt, you don't know the meaning, what will you do? Huh? You will say, good. Check it up, know the meaning. That's how to learn. Okay? Good. Not come here and tell me that you don't know the meaning of Epsom salt. Find it. That's how to learn. Good. Now, number B is what? Limestone. Limestone. C is clay. C is clay. The D is urea. D is urea. Now let's go back to number 3. Which one of the following changes is physical? Which one of the following changes is physical? A. Adding iron filling to aerated water. Aerated. A-E-R-A-T-E-D. Adding iron filling to aerated water. B. A-E-R-A-T-E-D. Option B. Adding sodium metal to water. Option B. Adding sodium metal to water. Option C. Option C. Cooling a solution of iron sulfate. Cooling a solution of iron 2 sulfate. Cooling a solution of iron 2 sulfate to obtain dehydrated salt. Cooling a solution of iron 2 sulfate to obtain dehydrated salt. D. Cooling water to obtain ice. Cooling water to obtain ice. Cooling water to obtain ice. E. E. The bubbling of chlorine into water. Bubbling. You know, no spelling of bubbling, like bubbling. B-U-B-B-L-I-N-G. Bubbling. The bubbling of chlorine into water. That is option E. Option F. The bubbling of chlorine into jar containing hydrogen. The bubbling of chlorine into jar containing what? Hydrogen. The bubbling of chlorine into jar containing what? Hydrogen. Which option am I going to mention again? Option G. The dissolution of sodium chloride in water. The dissolution of the dissolution of sodium chloride in water. Dissolution. D-I-S-S-O-L-U-T-I-O-N. The dissolution of sodium chloride in water. D. The passing of steam over heated iron. I think we'll stop here. So you can go on time, please. We'll continue tomorrow. Last option is the passing of steam over heated what? Iron. See how to answer this question. Don't just go and pick only the one you think is what is it called? Physical change. Tell me what the other one is. Hello? Why they are not physical change and what they are. Whether they are physical or what? Chemical what? Change. So if I call you out here to answer a question, try to, as you are doing assignment, try to find out which change these other ones are. So that if you come here when? Thursday, right? You'll be able to tell me exactly which one these other ones are. Is it clear? So go here into the world of internet and textbooks and research and answer the question, and you'll be glad you did. You'll be happy you did. All right. Any question? Ask. Okay. For really in physical change, actually, water exists in different states. At high temperature, it exists as what? Gas. Above 100 degrees Celsius, it exists as what? Gas. But it's still H2O. Hello? When they combine, they are formed as gas, H2O. But when the temperature goes down, they do what? At lower temperature, below 100 degrees Celsius, they exist as liquid water you are seeing. So the water you are referring to is liquid water. We have liquid water, which is the one because of the environment we see ourselves. That is the one you see. But the gaseous water is the one that is the gas we talk about. Am I communicating? Then the solid water, when temperature gets lower, is the ice that is formed, the solid form. It's still water, whether ice, whether steam, or whether the water you are seeing. All of them are what? They still water. Hydrogen combined with oxygen in the same 2:1. Am I communicating? Now, when they are formed, as the temperature drops, they become like ordinary water you are seeing. Does it make sense? Yeah, so it depends on the state and on the prevailing temperature. There are people in some part of the world, the water they see. There are people in some part of the world, they are not normal water they see in their normal environment is ice. Before they get the type of water we are looking for to drink, they will go and melt the ice to be in what liquid form. The same way, before we can get the type of water they see normal, we go and freeze our own water. So it depends on where you see yourself and the prevailing temperature. Does it make sense? All right. See you. Tomorrow's tutorial is in the other center. Okay? So try and come on time. And if you come, make sure you do the assignment. Come. Are you aware that come? Are you aware that you live in the same city? Yes. And you are going, you're not serious. Two of you should go. Huh? Any problem? Okay, you want to go alone? Are you okay? I go alone. Let I go alone. Be careful, okay? Huh? Be careful.